Welcome students. Today we will discuss about differentiation and Jacobians. So let's start. Let S be a non-empty subset of R2 and f S to R be a function. Let A comma B be a point in S. Then f is said to be differentiable at the point A comma B if f of A plus H comma B plus A minus f of A comma B is equal to H into the partial derivative of f with respect to x at the point A comma B plus k into the partial derivative of f with respect to I at the point A comma B plus xi of hk, where limit hk tends to 0 comma 0 xi of hk by root over x h square plus h square is equal to 0. Okay? If f of xy be a differentiable function, then del f del x into dx plus del f del y into dy is called total differential, and delta f of x comma y is equal to f of x plus delta x comma y plus delta y minus f of xy is called total increment. See, if fxy is differentiable function on the set S, then it means that it is differentiable at each point of S. Okay. Now, if we have to determine whether a function differentiable at a point or not, then we have to determine the partial derivatives of that particular point, and we have to find a function xi hk such that limit of hk tends to 0 comma 0 xi of h comma k by root over h square plus k square equal to 0. Okay. Now I will do some problems on differentiation, so the concept will be clear. Our first problem is, if f of xy is equal to xy x square minus y square by x square plus y square at xy not equal to 0 0 and 0 when xy equal to 0 0, then show that f of xy is differentiable at 0 comma 0. Okay. This function is very known to you because we have checked that this function is continuous at 0 comma 0. So how to approach? We have at first we have to find the partial derivatives of this function at 0 comma 0. Okay. So answer, del f del x at 0 comma 0 is equal to limit h tends to 0. See, f of 0 plus h comma 0 minus f of 0 minus 0 by h. Okay. Now what is f of h comma 0? It will be 0. So 0 minus 0 by h, and the partial derivative of f with respect to x at the point 0 comma 0 is equal to 0. Okay. And del f del y at 0 comma 0, this will be also 0. Okay. F of 0 comma 0 plus k by k, 0 minus 0 by k is equal to 0. Okay. Now we have to find the function xi of h comma k, okay, which is tends to 0. So I am erasing the board. Now what is f of 0 plus h comma 0 plus k minus this is equal to h into del f del x at 0 comma 0 plus k into del f del y at 0 comma 0, okay, plus xi of hk, okay. So what is f of hk is equal to xi of hk. F of hk is hk h square minus k square by h square plus k square is equal to psi of hk, okay. Now we have to prove that limit h comma k tends to 0 comma 0, this by root over h square plus k square is equal to 0, okay. Then our problem will be completed. So now limit is what is first like this. Okay, now what is hk sorry, I am using this only for that time. Okay, so what is this? See, hk h square minus k square by h square plus k square into h square plus k square, okay. Now we have to show that this expression tends to 0 as hk tends to 0 comma 0, okay. So what we have to do, see, I am erasing this portion, okay. We know mod of h less or equal to h square plus k square and mod of k less or equal to h square plus k square, okay. So psi of h comma k by h square plus k square minus 0 is equal to h square minus k square okay. Now we will apply these inequalities. Okay, so these are equal to we are writing these instead of mod h, and this instead of mod k. Okay, and this expression this expression is less or equal to 1. Okay, I am writing this. Observe that mod of h square d square is equal to 1. Okay, and we keep same this remains same. Okay, so is equal to h square plus k square. Okay, so here we have to assume an epsilon. Okay, we have to assume epsilon before this thing. So let epsilon greater than 0. Okay, then we have to find delta. If we have to find the limit of this function at the point 0, 0, then we have to assume an epsilon and we have to find a delta. Okay, so less than delta less than epsilon where when h square plus k square less than delta square where delta is equal to by epsilon. Okay, so limit h comma is equal to 0. Okay, these steps are known to you. Okay, these are nothing new. So we have find psi of hk such that limit of h comma k tends to 0 comma 0 psi of hk by u by h square plus k square is equal to 0. So f is differentiable at 0 comma 0. True. So when you are asked to show that a certain function is differentiable at some point, then you have to find just partial derivatives of that function at this point and that point, and you have to find psi of hk such that limit of h comma k tends to 0 comma 0 psi of h comma k by h square plus k square is equal to 0. Okay, now our problem number 2 is show that f of xy is equal to xy by root over x square plus y square when x comma y not equal to 0 comma 0 and 0 if x comma y is equal to 0 comma 0 is not differentiable at the point 0 comma 0. Okay, so here we will do the problem. Here we will show that the partial derivatives of f of x y at the point 0 comma 0 will exist. Okay, but that function psi of hk, that function will not exist at the point 0 comma 0. Okay, so in this way we can conclude that this function is not differentiable at the point 0 comma 0. So answer. At first we have to obtain the partial derivative. Okay, so del x at the point 0 comma 0 is equal to limit h tends to 0 f of h comma 0 minus f of by h, but f of h comma 0 is 0, so limit h tends to 0 minus 0 by h, and which is 0. Okay, and similarly del f del y is equal to 0. Okay, easily you can understand that will be 0. Okay, now if possible let f be differentiable at the point 0 comma 0. Okay, so f of 0 plus h 0 plus a minus f of 0 comma 0 is equal to h into 0 plus k into 0 plus psi of h comma k. Where limit h comma k tends to 0 comma 0 this is 0. We assume that. Okay, but you will see that this is not happening. Now psi of hk, let epsilon greater than 0 is equal to, what is psi of hk? The psi of hk is, see, if we put the values of if we determine the f of h comma k, so what is this? H k by h square plus k square, and which will be psi of h comma k. Okay, this is psi of h comma k. So this is h comma k by root over h square plus k square which is Remember, when we were trying to find the limit of this function at the point 0, 0, we have chosen a path y equal to mx. Okay. So here we will choose that path. Okay. So now letting h comma k tending 0 by approaching k equal to mh. Okay. So we have to erase these lines. So limit h comma k is equal to limit h tends to 0, and what is k? K is mh. So we put the value of k. Okay. And from the numerator and the denominator, h square will be cancelled out, and the expression will totally dependent on m square or on m. Okay. So the expression is dependent on m, and m can take various value because m is a real number. So such function psi h comma k does not exist. Okay, does not exist. And if is not differentiable at the point 0, 0. If it has to be differentiable, then this psi of h comma k has to be exist. Okay, but this type of psi h k doesn't exist. So if is not differentiable at the point 0, 1. Sometimes we can check non-differentiability of a function at a certain point by continuity. Okay. See, there is a theorem that if S2R be a function, okay, where X is subset of R2 and X is non-empty. Okay, then differentiable at a point a comma b from S, then f is continuous at the point a comma b. Okay. See, but if we think the statement contrapositively, which means f is not continuous at a comma b implies f is not differentiable at a comma b. Okay. For an example, if you consider the function f of xy is equal to xy by x square plus y square, when x square plus y square not equal to 0 and 0 on this 0, then you can show that f is not continuous at the point 0, 0 and which implies f is not differentiable at 0, 0. If you are asked to show that f is not differentiable at the point 0, 0, then if you show that f is not continuous at the point 0, 0, then you are done. Okay. Now our third problem is show that the expression 4x plus y into dx plus xy 4y into dy is a total differentiable of some function and find the function. Okay. Next one. Let p is equal to 4x plus y and q is equal to x plus 4y. So del p del y is equal to 1 is equal to del q del x, and hence 4x plus y dx plus x plus 4y dy is equal to d of u xy is equal to du dx del u dx plus del u dx and dx plus del u dy into dy. Okay. Here we and y are independent. So let value del x equal to x plus 1 and value del y is equal to x plus 4. This is 1 and it is 2. Now we are integrating 1 with respect to x, and when we integrate 1 with respect to x, then we will assume that y as a constant, and when the integrating constant will occur, that will be a function of y. Okay. Now integrating 1 with respect to x. No, now integrating 1. Okay. We have u is equal to 2x square plus xy plus phi of y. Okay. Remember, here we have assumed that y as a constant. So the integrating constant will be function of y. Okay. Now, and if we partially differentiate u, with respect to y, okay, then this will be 2x square 0, partial differentiation of 2x square with respect to y is 0. This will be x and this will be phi dash y. Okay, and it is, and what is del u del y? X plus 4y. So this is x plus 4y. Okay. From 2. Now what we have? We have del u del y is equal to del u del y. No, not del u del y. We have to determine phi y. So we have phi dash y is equal to 4y, and phi y will be 2y square plus c. Okay. See, we have u is equal to 2x square plus xy plus phi y, and we have determined what is phi. We have determined phi y, and here the phi y is 2y square plus c. So u is equal to 2x square plus xy plus 2y square plus c. Okay. So u is that function for which the differential is this. Okay. Now our first definition is, if xy and gxy are two differentiable functions in a set, non-empty set as subset of R2, then the Jacobian of f and g with respect to x and y is the determinant of del f del x, first row del f del x, del f del y, and second row is del g del x, del g del y. Okay, and this is denoted by del of f comma g by del of x comma y. Okay, these are partial derivatives, you know, and if f, g, h are function of three variables, and if they are differentiable functions in unbounded set S in R3, then the Jacobian del of f g h by del of x y z is equal to determinant of this. Okay, these are similar. Okay, just this is 2 cross 2 determinant and this is 3 cross 3. Now the chain rule for the Jacobian is if z1 z2 be two differentiable functions of y1 and y2 which are differentiable with respect to x1 and x2, then Jacobian of z1 z2 with respect to x1 and x2 is equal to Jacobian of z1 and z2 with respect to y1 and y2 into Jacobian of y1 and y2 with respect to x1 and x2. Okay, now I will do two problems on this and on this. Here our problem is if x equal to u minus v and y is equal to u square minus v square, find the Jacobian of xy with respect to u and v. See, here x is a multivariable function, okay, u and v, and y is a multivariate function of u and v. So this Jacobian is valid. Okay. Now we have to determine the partial derivative. Okay, so del x del u is 1, del x del v is minus 1, del y del u is 2u, and del y del v is equal to minus 2v. Okay, so the Jacobian is very simple problems. Okay, just you have to calculate the partial derivatives and determine it. So first row is del x del u del x del v, and my second row is del y del u del y, sorry, this is u. Okay, okay. Now what is del x? My del x is 1. What is del x then? Minus 1. What is del u del y? 2u. And what is del y del u? Minus 2u is equal to this minus this. So 1 into 2v minus of minus 1 into 2u, which is 2u minus 2v. Okay. And our problem 5 is if u is x square plus y square, and b is x square minus y square, where x is equal to r cos theta and y is equal to r sin theta. Okay. Then find the Jacobian of u and v with respect to r and theta. See, here you have to apply the chain rule because u is function of x and y and v is function of x and y. But x and y are function of r and theta, and we have to determine the Jacobian of u and v with respect to r and theta. So we have to apply the chain rule. Okay. So del u del v is equal to uv by del of xy, and del of xy is equal to del of r comma theta. And what is del u del v? That is del u del x, del u del y, del v del x, del v del y into del x del r, del x del theta, and del y del r theta. That's it. Calculate the partial derivatives. Okay. This is common, and now I am stopping my class. Okay.